so looking at stoichiometry and this, we have a skeleton equation here. And looking specifically at mole ratios first and foremost. Because we've talked about balancing equations. And I gave you the worksheet on how to balance equations. You'll give me that at the end of the hour. Now, this is your skeleton equation. We need to balance this. So, you have 1 sodium. Chlorine, you have 2 of them over there. Why do we have Cl2? Because it's diatomic. It's diatomic, so you have to have Cl2. Have no other fear. Chemistry is beautiful. Over here, we have 1 sodium. And we have 1 chlorine. Now, we have to balance this equation. So to balance this equation, I have 2 chlorines and only 1 chlorine over here. The sodiums are good. Now the chlorines, so I need to put what coefficient in front of the 2? Alright, so I need a 2 there. But that's going to do the chain reaction thing where it's going to change everything in that compound. So now I have 2 and 2. But the nice thing is sodium's all by itself over here. It's a lone element. So what do I have to put in front of sodium? 2. Now, that's balanced, we're good to go. Now, what I didn't tell you first right off the bat with these coefficients, you have 2 here, you have a 1 here, and you have 2 here. The coefficients represent the number of moles so it represents the number of moles needed for each reactant to get the number of moles of product. So this is saying that I need 2 moles well, this is what it's saying. You have 2 moles of sodium plus 1 mole of Cl2 is going to get me 2 moles of NaCl. And from here, we can develop what we call mole ratios. And they're basically conversion factors. So if I gave you, for example, the amount of sodium or the amount of chlorine, we can actually go and work through these because we can convert all these moles. So you can come up with 2 moles of sodium over like 1 mole of Cl2. That's a conversion factor that you can have. That's when you this is the mole ratios. So you can get like 2 moles of sodium to 1 mole of chlorine. Or you can get 2 moles of sodium to 2 moles of NaCl, or you could do the 1 mole of chlorine or Cl2 is going to get you to 2 moles of NaCl. So you can develop these and you can actually come up with the reciprocals too to come up with any kind of conversion, because now once we actually are able to balance the equation, we lock these in. These are the number of moles that we have. 2, 1, and 2. So for every 2 moles of sodium, I need 1 mole of chlorine in order to make that reaction actually work. But the ratio helps us to determine, all right, well, let's say we have certain amounts of these reactants. Are we going to get those to work? And that's what I want to talk about next. But are there any questions on mole ratios? At first, I know when we were balancing equations, we weren't talking too much about anything outside of making sure that the number of atoms on one side were equal to the number of atoms on the other side. Now we kind of see that those coefficients represent moles. And that's going to be a huge thing.